So, okay, today's session is to make the meta presentation of the second lecture of the Introduction to the Cybersecurity course, in which we introduce again what is security engineering. This is a quite hard session in the sense that this is a typical session that would require like I don't know, 10, 15 more hours to go in depth into different contents, or just like an hour, 2 hours for learning the main concepts, the main ideas, and so on. Because in this session, different methodologies, standards are introduced, like the typical ISO standards and so on, which, if you want to understand, require lots of time. So, as I said, the duration of this session, I mean, in the real lessons, in the real teaching, can be adapted to a lot of configurations. I mean, this can be less than an hour, 2 hours, or much more. So, what is this about? Well, in fact, we have prepared like 89 slides, which is a lot. So you will probably have to make a selection of the contents or of the slides, and not show all of them, because they are going to be probably excessive. So the idea for, as I said, the main idea for this session, for this week contents, is to try to explain and to show the main elements that are used in security engineering, how to say, in a security engineering concept, in security engineering methodology, in that kind of profession. I mean, understanding the security not only as a knowledge, but also as a set of procedures that have to be applied to obtain the desired result. So in this case, it's just to understand the elements we have, the different standards, the different methodologies, the different formal proposals to make systems secure, the formal proposals to implement also in a company the procedures to provide security, and so on. As I said, this can be really, or at least for me it is, it can be really hard, a really hard session, because the topics are not so interesting, I mean, from a point of view of learning, but they are more procedural, they are more related to formal steps that we have to follow, and so on. Okay, so mainly the contents are, as I said, the concepts, the security models, and the architecture. Different also concepts regarding the controls and countermeasures that we may apply when we define that kind of methodologies. And also at the last slides are about the main vulnerabilities, problems, and mitigations we can apply in different systems, web systems, mobile systems, and embedded devices, and physical systems, including the industrial devices and industrial environments. Okay, so the first step is to explain the students about the more or less what I was discussing the last minutes. The relevance of this kind of methods and this kind of standard procedures to make sure that the results are at least more or less satisfactory. I mean, to have a standardized way to work to provide security in an organization, and to provide and to be able to assess that security, to be able to know if the procedures we have are right or not, and to simplify our life as engineers to implement that kind of procedures. Mainly the relevant concepts are related to the models and processes, also the methodology to secure the information that is stored in the systems of the company, and also the systems, and also how to create, I mean, the different proposals that exist to create a secure life cycle for the environment, for the systems, and so on. You are going to need for this session also the lecture notes. Oops, I'm using the wrong keyboard. As you know, the lecture notes are available. For different sessions, they are not really necessary because most of the information is already in the slides. So with the slides and good knowledge about cybersecurity, you are going to be able to present the contents without any kind of problem. But in this case, from my point of view, of course, I think that you will need to use the lecture notes to be able to present the different slides to your students. I think there is a lot of information also in this document. And in this section, you are going to find more or less the explanation of the different of the contents of the different slides. And as I said before, I would recommend you to using this information to decide what you are going to present to your students or not. Especially for some slides that are more conceptual and that don't provide a lot of text. I would also recommend you to use the bibliography to have to get more information, because also, as I said before, we are, for example, you have here different links that is for the last part, and the bibliography, the references also to the different standards are, if I am not wrong, here at the end of the At the end of the section about this week, you will find the different documents that we use or we reference in the slides. Probably the most relevant is the CISSP official guide, which provides a lot of information about these different methodologies, formalisms for providing security, and also, of course, the different standards that we mentioned in the presentation. But if you want to go there, you will need a lot of time, because they are complex standards that provide a lot of information, and that will require a lot of time for understanding them, to read them in depth, and to present them to your students. So probably I think that probably that is not very interesting. Okay. So as I said, this slide is just to try to introduce the different elements, the different topics that we are going to address in this module, and then we start with the first one, which is about what is a security engineering process. You will have to probably define what a security engineering process is using the lecture notes, and then here we present the main characteristics, which more or less by definition has a security architecture that we build following the security engineering process. Mainly the different topics you see there. I mean that this kind of security architecture has their own security methodology, has its own discrete views and viewpoints of the methods and of the security, address the flows through the system and through the applications, creates their own normative flows among systems and applications against, and introduces specific proposed components for security in the design of this architecture, and also that requires as trained engineers to use this kind of security architecture and procedures, because usually because of the more than the complexity, the need for following a set of more or less complex or elaborated steps. Also, I didn't say this before, but if you want to make questions, you can interrupt me at any moment. Okay. After that, also is relevant to start introducing the different elements that are used in this kind. Sorry, I have problems with the mouse. Maybe now. Okay. Okay. Is the time in this slide to introduce the different standards or different procedures that are available for different parts of the architectures, of the security architectures that are available for using for providing security. The different ISO standards, the international standards about directly systems and software engineering, because the first part to be able to provide a secure system is to provide structured and robust software. Also, the system security engineering manual, and also the other the standards provided by other standardization organisms like the American one, the NIST. Of course, what we are providing here is just a list of some of the different standards. There are lots of standardization organisms, and most of them are providing now different manuals, standards, procedures, and so on for following the best practices to implement secure systems. Also, every country or most of the countries have their own regulations, their own recommendations, and so on. So maybe you can also adapt these slides and provide information you consider relevant in Jordan instead of for example, the American standard or the European standards. Of course, the international standards are relevant. Okay, so as I said, the first set of standards we have to be aware is related to system and security engineering. As I said, these are three commonly used sources, but others can be added. The next step is going not in depth in these different documents, but just review them. For example, the ISO 15288 covers, as we say there, different steps, different stages of the life cycle of a project. So I wouldn't go in depth here, but it's up to you to decide to provide explanations about the different stages of the different parts of this standard. The same for the others. I mean, for example, in this case, the ISO 21827 provides describes the characteristics of the engineering process in an organization to of course to be sure that the security engineering is okay, and it includes different practices and different elements or parts in the organization. I mean, for example, it provides the essential characteristics of the life cycle of the project, of the application, of the software. Also the information related to management and organizational activities and engineering activities in the company. Also the different good practices that we should follow in different elements of the project or the product the company develops or just the service they provide and so on. And also it studies or it provides recommendations for the different relations in terms of acquiring whatever, I mean, software elements, even interacting with other people, the management of the systems, what we should do in terms of certification, accreditation, and final evaluation, and so on. In fact, we will see also the different also the recommendations in these specific parts. But in this case, this document provides the high-level view of all the characteristics of what an organization should follow to try to provide a good security engineering, as we said. Okay, and regarding the American standard, the NIST is more or less the same. In this case, it provides a lot of information. Again, it tries to provide methodology to obtain good results, and it divides the planning of the security engineering in different stages. In this case, in 5. First of all, the initiation, which is more or less an assessment of the impact that will have these different procedures in the company. Also obtaining the different requirements and create the specifications. Then how this engineering architecture is going to be implemented. Then how it is going to be maintained, and finally how information also has to be removed when it is not necessary, and to avoid, as always, to lose that information in hands of third parties that should not have it. It has also, it provides, like, if I recall correctly, well, more than 30 different principles that should be followed using these recommendations. And in this presentation, you can, as I said before, go in depth and review all of them, or just, as I'm going to do now, just let the students know that this standard provides all these kind of principles that they are described in the different documents, and that if they need them, they can go to the document and try to understand them and so on. As you can see, they are organized in different typologies in terms of risk, in terms of facilitating the usage. In fact, in this field, there are lots of principles, also to design the network and so on. Okay, now in this case, after we saw the different standards, then we can show also how companies provide or use or provide also how to say their own implementations. In this case, this is an example of the framework that was built by Cisco to improve, and this is like a framework to improve their products, the resilience and the reliability of their products. And in this case, they provide this information to the public. And as I said before, you can, in the lecture notes, you have descriptions of these different elements. So you can just show this as an example of an implementation of these engineering principles in a company, in this case, for the development of a product, not for the typical internal procedures. And as I said, you can just mention that this is an example, or you can go again to the lecture notes, and you should have, let me check, let me search. Okay. As I said, I hope you see this. As I said, in the lecture notes, you have described the different components that are shown in the presentation. Again, it will depend a lot if you want to go more in depth in the different elements or not. To try to make this session a bit lighter with a practical example instead of all this information regarding the standards and so on. Okay, in fact, I think I am going too slow because, as I said, we have like 89 slides and I'm still in the 13. So I will try to go a bit faster because I don't want to explain the contents. I would like more to explain the different options you have for the presentation of these contents. Okay, so the next block is regarding the different security modules and and architecture that are available for following. The first one thing that we have to know for explaining the models, the different security models and the architecture of that security models, is to understand the elements that are involved in such models. The first one is to explain that there are this kind of taxonomies about the different components and the common components all the systems have. And in this case, what we will explain is just the typical elements that we will find in any architecture, in any infrastructure, which is it is built with processors, with storage devices, with software operating system, with peripherals, and with the network and so on. Then you can explain the different features that we have in the different elements of in the different components that we saw in the previous slide. For example, in case of the processor, just explain the different elements we have, also the key features in the processor, in the main processing component, and also the different characteristics that will affect probably the architecture, the security of that component. Then also explain some of the mechanisms that are available for protecting that component, in this case the memory, the different components, the different methodologies we have now to try to avoid that an application is affected by other application that maybe another potential application that could be malignous. Other elements, like in this case, also for programs, the technique about randomization of the address space to avoid malignant applications that try to modify the information that other application has, and so on. Okay, that regarding the common components we have for, I mean, to understand the common components we have in a typical system. And then we can also present this enterprise security architecture, which is just a proposal, a standard proposal that tries to create a long-term vision for security services in an organization. And the main goal of this enterprise security architecture is to establish goals for security service creation by providing an insight into information security preparation. I mean, a program, as we can see here, that understand that all the information is not exactly equal and in terms of value and risk, and so that tries to protect the critical assets and not everything. And it has different aspects, different facets, different goals, as we see here in this other slide. Here we provide also in the left part the key goals and then the benefits of this kind of enterprise architecture. Also, different types of services provided by this kind of architecture, as an example of an architecture, and so on. Okay. Also, the idea here is to explain that architecture as an example, and also to introduce different frameworks that are useful for companies for identifying and create a representative, as we say here, a descriptive representation, a model of the assets or everything in the company to build that kind of security architecture. In this case, most of them follow the same principles. I mean, what they provide is some kind of framework of methodology to help the security engineers to organize the information and to be able to provide the tools to protect the critical assets that we saw before, and to also when they have built that architecture, to be able to evaluate if the final security architecture operates as expected or not. The different frameworks, there are different ones, as I said, the different frameworks are more similar, and you can find very brief introduction in the lecture notes. In this case, if you want to go, I mean, if you want to explain then the different frameworks correctly, you will need to use one of the books that we use it as a source of the information that are in the references, or just search in the internet about this kind of frameworks, and you will find more information. Other one is the SAPSA model, which is, as you can see, similar, but it just provides different. I mean, it just organizes the information in a different way. Also, the different frameworks have usually different objectives in mind. I mean, some are focused on the information, others are more focused in the security, some are focused on trying to avoid corruption of information, others in access to the information. So they are more or less similar, but they have different focus. So the aspects they study are, I mean, despite the procedures and the way to work are more or less similar, as they are focused on obtaining different results, there are also small differences. So also, if you want, you can put the focus on that differences and try to provide some kind of taxonomy of these frameworks instead of just providing these different examples that we have here. Okay. Another one. I'm not going to stop here. And okay. The next block is another classification, in this case, examples of security models that are available in the literature. In this case, these models are, as I said before, focused on different results, and we can see, for example, this Bella Padula, which is focused on access to the information. I mean, what this model looks is to implement an architecture that tries to avoid the disclosure of information. Other models, what try is to avoid the corruption of information, and so on. Okay, so these are different examples. I'm not going to stop here. In this case, the slide is just a comparison of the different models. Also, these different models, what they do is to provide like different procedures, different methods, and they classify the different procedures, methods with different levels of security. For example, it's simpler to access to the information, but harder to write the information, and so on, depending on the expected results. As I said, you have here a small comparison, and the compromises. What they look for with this model, with implementation of this model in a company. I mean, for example, disclosure, contamination or corruption of information, and so on. Other models, for example, this is for integrity, which tries to show how we protect the information or the objects, the elements, the relevant elements, and we force new paths to access to this object or this information. I mean, we disallow the direct access of subjects to the information or to the elements, and we force standardized paths to make the system more secure. Also, I insist a lot, but as I said before, if we want to have a deep understanding of all these different elements, it will require much more time. So again, also, you should probably decide to remove parts of these different slides and adapt them to your idea of the course, because it is too much information. Other different models we have here, and I'm not going to explain them. Okay. The next section is regarding the different, again, standards and methodologies we have to control how to access to the information systems, or also how to apply countermeasures to minimize those possible attacks we might have. This section is going to be divided in these 4 different particular explorations. I mean, these 4 typical standards and methodologies. The first one is, well, before, it's important to, in this case, also to talk about how a system or that kind of risk is evaluated, and also to differentiate how what is certification and what is accreditation. I mean, certification is more or less evaluating if the different methodologies and standards have been applied correctly, but usually internally, and accreditation is this evaluation, but completed by a third party, completely external. I mean, certification is usually a third party, but it has not to be external or completely independent. And for accreditation, it has to be completely independent, and usually a company or an organism that works just for this kind of results. And of course, the objective of these different certification and accreditation is to understand, well, first of all, to understand if the measures we have applied in our organization with this security engineering, because the different security engineering tools and the architectures, to understand if they are applied correctly. And probably what is more important nowadays is to make clear to the other companies, institutions, and so on, that we have applied those methods, and so to make them feel comfortable with us, and of course we are not going to be safe in front of any kind of attack, but at least to be able to make them trust us a bit more, because we are addressing that kind of risks and not just forgetting about them and not doing nothing. Okay. Okay, also we can explain here the different steps we need to follow in a certification or accreditation phases. What I mean, we can explain how the product or a device, or even we can put an example how a product or device is going to be checked during the certification process to determine if the criteria that was documented is completely satisfied, or and also how that product or service or even our procedures are going to be endorsed by this institution that is accrediting us. Okay, one of the, as I said, one of the standards for this, yeah? Oh, sorry, I thought I heard some noise. I thought there was a question. Okay, here we have 2 examples of 2 evaluation criteria of 2 institutions. In this case, the Department of Defense of the United States uses this evaluation criteria, the DCSIC, which asks them to, I mean, they ask for this certification for certain products that if we want to sell to them, and also other criteria like this ITSIC and so on. Other very relevant one is what is called like the common criteria, which is the ISO IAT 15480, which is very common. In fact, probably you have heard about it. We have the table of the different levels of certification provided by this standard here in the lecture notes. If I am right, these are the different levels that we can have, that we can obtain in the ISO IEC certification, which goes from level 1, which is just that the functionality of the system was tested, and the level 7, which certifies that the system was formally verified and completely tested. And you have different intermediate levels in the middle. Okay. Which is in fact this EAL level, which is the evaluated assurance level, which was obtained if you pass this kind of certification. Also, it's relevant to more or less understand the different names that are used in these certifications, but probably your students are not going to require this kind of information. Probably, if you just provide them with a list of different certification examples and so on, just so they are able to recall that procedures and to more or less know that they are available and to be able to go back to them when they need them is more than enough. I don't think that this, I mean, personally, I'm not in favor of forcing students to study a lot of things that they are not going to use in their day-to-day. So this is not a skill they need. They just need to have probably this information so that when they start working, they can go back to these slides and have some information that they can use. But I would not ask a lot of from them regarding the contents of these slides, because, as I said before, also I think they are a bit hard, and this is information that you not need to have in your head. You just need to know where to find this kind of information. Okay, another standard in this case, which is in this case another certification. Sorry, in this case focused on the management of the information security management systems. Again, it has different components, different blocks that are analyzed by this certification. Other one is the ISO IEC 27002, which provides the code of practice for information security management. In this case, is the meta security. I mean, how we should manage the security of the information. And again, it has different key areas of focus, more or less the typical ones. I mean, the policies, the security of human resources, the management of the assets, the control, the access control of to the assets, the different methods to protect those assets from ciphering and so on, limiting the physical access and so on and so on. Other one is this certification, which is an alternative one, which provides a set of generally accepted processes to assist in maximizing, as it says here, the benefits of using the information technology, but without risking the security. Okay, so it provides the mechanism to build the minimum services for an organization that they will require to implement to provide at least the basis to operate without risks. Again, in the lecture notes, there are different details about this certification, and also how they categorize the enablers and how they provide, I mean, the different principles they use to build these base minimum security services. Finally, as another example, in this case, regarding the physical security of in this case, a relevant element is, as I said, just an example for a particular field. In this case, is focused just in the different. I mean, the objective is to provide the security architect with a framework of the different specifications that will allow him or her to ensure the safe processing, storing, and transmission of the information of the call holder of a card, a security card. So in this case, it's just a particular framework for this particular field. But I think it's interesting also because of the relevance of this kind of applications. Okay. Now we change more or less the subject, and after viewing these different certifications, standards, and so on, to help the security architect to build a security environment, it's interesting also to provide the students with the different countermeasures they can implement also for building that security architecture in a company or in a institution. Again, you can go in depth or not in the different elements shown here. Also, some design, some considerations that we can provide them to create this kind of security architectures. For example, some guidelines or at least some points they have to have in mind when they try to create this architecture, like the framework they should use, what they have to take into account related to the business, to the company. Also be aware of the stakeholders of the company. I mean, they may be not only the owners of the employers or the employees. I mean, they can be the clients and so on and so on. And that is also the considerations from the point of view of management. I'm not going to stop in them, but if you want, I can. But I don't want to stop because we have still a lot of slides pending. But as you can see, this is more or less the same. I mean, it's just the different topics that the security engineer should have in mind to provide this security architecture. So these are like recommendations for implementing the architecture or for implementing the framework, using the frameworks or trying to obtain a certification. As you can see, the information here is or was a bit dense, so that is why I insist again in reducing the amount of information that you show to your students, because if not, it's going to be too much. And now what we are going to see is different recommendations or different mechanisms to assess and mitigate the vulnerabilities that might have an architecture that we design, a security architecture. First of all, what we need to know is what are the typical vulnerabilities and threats in an architecture that we may design. Of course, explain the what is vulnerability and how we can assess it, and review. And this, of course, again, this is an introductory session. I mean, not this one, but the one you are going to show your students. So these different threats are going to be studied in other lessons. So in this case, we can just put, name them and not explain them, because they are going to study the different threats in other lessons. Okay, so also what we want to show now is different resources for, the students can use for assess and mitigate. The first one is related to web application. Probably you know this project, the OWASP project, because it's really interesting. And if you don't know it, I recommend you to go to their website, because they have very, very interesting resources for teaching, and of course for security engineers. In fact, as it says here, they are an organization that provides information regarding the threats, and they have information how to address them, and in fact they have also even tools for teaching to help students to understand how to protect different components like software. Originally it was focused on web applications, but they also provide information for IoT and mobile projects and so on. Direct links are provided here, so to use them directly from here with more information. And then also a quick introduction of the different vulnerabilities we can have in different products, depending in if they are web-based products, mobile-based products, or embedded systems, IoT systems, industrial systems, and so on. I'm not going to stop also. As I said before, this is just an introduction for the students about the different vulnerabilities and how they can assess and mitigate them with their security. The vulnerabilities that they might have in their security architectures, in the security architectures they develop, following the different procedures and standards, and so as they are the typical ones, how they can mitigate them. So these are just examples for them. So regarding web systems, here is the list of the typical or of the top 10 vulnerabilities. The description, as you can see here, the WASP project provides very good contents for understanding the different problems. Also, different suggestions for mitigating this kind of problems. A bit more. Also, input validation, how they should use input validation and so on to avoid problems from remote attackers and so on. As you can see, just a very quick overview of the main problems and the mitigations. Regarding mobile applications, more or less the same. In this case, try to the main problem is not usually the remote attacks, but I was thinking that in fact nowadays mobile applications and web applications are very related, because most of mobile applications are linked to a web backend. So in this case, usually you will have to, if you are in the mobile applications world, you will have to follow also the recommendations for web applications for protecting the backend. But again, in this case, just a description of the main vulnerabilities, like the problems with jailbreaking, or not having a good connection with the backend, a secure connection with the backend, and so on. The different vulnerabilities, different content measures, and so on. Okay, also related to tunnels and the connection with the backend, with the different endpoints we have in our architecture, and so on. The different attack vector we might find. And finally, of course, the different standards which we have already available for trying to manage the mobile, not only applications, but mobile devices. For example, this NIST recommendation, which provides the good practices for managing the security of devices in the enterprise, how to be able to provide workers with mobile devices and try to avoid the typical risks, leakage of information, attacks, stolen devices, and etc. Okay, finally, the last set of the last example, which is the first one was was web applications, mobile applications, and now embedded devices and cyber physical systems, which are very, I would put a lot of emphasis in this set, because these kind of devices have the particularity that they interact with physical systems. I mean, these kind of devices are usually connected to actuators that interact with machines, with, for example, water systems, electrical systems, and so on. So if one of these systems is attacked and becomes controlled by a hacker, then we can be under physical risk. So that is especially dangerous. Okay, so regarding the requirements of an embedded system, is more or less like any other system. I mean, confidentiality, integrity, and availability. The different threats we have in the different embedded systems, also the typical. I mean, probably the main difference, I mean, other systems usually have network attacks like servers and so on, other software attacks, but the difference for embedded systems is that they are usually distributed in lots of places, and attackers can, I mean, they are hard to protect, to protect physically. For example, a smart grid or something like that is going to be deployed all over a country, so it's almost impossible to provide physical security to all the devices. So usually, when we are talking about embedded systems, we have to put a lot of focus here in the physical assets. So that is probably the main difference. Okay, again, the categorization of the different attacks. I mean, following the previous slide, the different potential attacks and the different countermeasures, like we saw for the mobile applications. Also, we talk here about define or put samples of the typical cyber physical systems, and a particular subset of them, the industrial control systems, which are especially critical because they control usually machines, even some products, for example, vehicles and so on, which are especially critical, as I said. More examples of the application of these systems, just to put focus or to emphasize the relevance. Modern challenges that we can have in with those systems. A bit of information, again, with most information about the industrial systems of the different, subsets, the SCADA systems that are controlling the machines, PLCs, which are programmable devices. Traditionally, they were very embedded devices which were programmed with very specific languages, but nowadays they are computers. So they are very easy to attack and so on. So again, you can use these slides to go a bit deeper into the explanation of the different industrial systems and their risk and their potential problems, or you can just skip these slides. More information, for example, in this case about the SCADA systems. And finally, or almost finally, the main threats for this kind of systems, and the different standards that are relevant for the cybersecurity of this kind of embedded systems. Again, standards from the ISO, from the IEC, from the NIST, and so on. Finally, some recommendations and different tools that can be used by the students to identify the attack taxonomy and classify them. In this case, for example, the preconditions, the vulnerabilities, the methods of attack, and the effects of attack, and so on. And okay, it's 1 hour later than when I started, more or less. As you can see, I went very quickly over some of the slides, and I required 1 hour. So as you can see, this is a lot of content. I hope you got an idea of the idea we had when we prepared these slides, and I am open to questions or comments you might have. If you are still awake.
Thank you very much. Just one question. So the material that we want to teach is actually depending on what we want to cover and the students' interest. So it's not like limited to a certain context or certain material. So we can go in depth with some subjects and others, like just we go slow with them. Is that correct?
Yeah. Yeah, at least that is my view. I mean, because it is very difficult to provide a completely standard material for all the different profiles of students we may have. I think Saud is not here. I mean, I am not sure if this is his view about the results of the IREEDER project, but for sure is my opinion. In fact, regarding this particular session, I am not completely sure if I would use this material in a course. I mean, because this is a typical session that is very, I mean, focused on the standards, on practices, and so on, and maybe it's not the most useful for an introductory course. So, in fact, if I am the person that is going to teach the complete course, I would maybe reserve this material for the end of the sessions and use it only if I have time. I mean, maybe go with more practical materials and avoid using this one. But it's just an opinion.
Yeah. Okay. Thank you. I understand. Thank you.
Okay. If there are no more questions, I think we can close. Okay, and see you tomorrow.
Thank you. See you.
Thank you.
Thank you very much
Thank
for
you.
your time.
Thank you
Bye-bye.
very much. Thank you. Bye bye.
Yeah, tomorrow is René is at 10 Jordan time.
Yes.
Like today.
Thank you.
Yes.
Yes, Jordan time at 10.
Okay, so see you tomorrow. Bye bye.
Bye-bye.